Hi, in this video we are going to look at this word problem where we're given some information about costs and demand, and we are going to look at writing equations for the cost, the revenue, and the profit for what is described in this word problem. And then in a follow-up video we'll do some more things with some of these equations and examine what they tell us. All right, so some basics to remember. Cost is given by fixed costs. Those are things that a business owner is going to have to pay no matter whether they make any donuts or not. So things like rent and or maybe employees, if they have employees and they have to pay them no matter what. So fixed costs, whatever those might be for the company, plus the variable costs. And those would be costs that would depend on how many donuts, in this case, the business owner made. And so certainly you could have much more complicated situations, but we're going to start out with this fairly simple one where we've just got some simple information here about fixed costs and variable costs. So let's start with that one, and then we'll look at revenue and profit. All right, so we want to write a function equation that gives costs equation. And so we're going to kind of pay attention to all the information here. We've got some information about fixed costs. We've got some information here about variable costs. This is cost per donut, so that's going to depend on how many donuts the owner makes. We've got some other information here about a demand equation. And it tells us after that what the variables in that equation represent. So P is the price she's able to sell the donut for, and X is the number of donuts sold. So we're going to use that variable in our cost equation using X for the number of donuts sold. So for our cost equation, we're going to have cost, so C, or whatever variable you want to use to represent C, or our textbook often will write C of X to remind you that that C is a function of X, the number of items sold. All right, so in this case, we're just told what the fixed costs are. We didn't have to do any work to figure that out, so we're going to put that here. And then variable costs. So the variable costs are 37 cents or $0.37 per donut. So if she makes one donut, it's going to cost 37 cents. If she makes two donuts, it's going to cost 2 times 37 cents. And so because X is the number of donuts, we're going to say that our variable costs are 0.37x. All right, so this x here is assuming that however many donuts she makes is also the same as the number she sells. In a more complicated equation, you might have some different variables to represent the number made, and then maybe she doesn't sell them all. But we're letting x represent the number of donuts sold and made. All right, so this is our equation. There's one other piece of information that will be relevant when we do some other things with this. She can produce up to 2,000 donuts a day. And so that would be telling us what values our x can have here. So this is really a domain restriction on this function. Domain, remember, being the values that the input variable, in this case x, could have. So she could not make less than 0 donuts. She couldn't make a negative number of donuts. So we could say that x is going to have to be greater than or equal to 0. And then up to 2,000 donuts a day. So she can't make more than 2,000 donuts a day. So our x is going to be between 0 and 2,000. And really here, probably only makes sense to think about whole number values for x. I'm not going to write that down, but when we do some analysis and think about what these equations tell us, we might want to think about that this x is number of donuts, so we can't really have a fractional number of donuts that she makes or sells. All right, revenue. So revenue equation, you'll want to make sure that you remember this. Revenue is going to be the money that that comes in to the company, and so that is given by the price that you charge per item times the number of items sold. And in this case, the price is not fixed. If she's got a demand equation here, So kind of slightly more complicated than just a fixed price that she's going to charge, say 99 cents a donut or whatever, but she's got a price equation here. And so she's got a variable for the price she sells each donut for. And so in this case, I'm going to have revenue. I'm going to use R, and our textbook likes to write R of X. You could also just write R of X equals. And then in place of price, I'm going to use what they've given us here. I could put P, but because P is given to us here in terms of X, and I want my equation all in terms of X, if I'm going to do some more things with it, I'm going to put this in for price. So here I will have 10 minus 0.005x, and then times the number of items. And remember, that's what our X is. All right, because we're going to do some more with this, I'm going to go ahead and distribute the X through the parentheses here and rewrite this in a slightly simpler form. If you weren't going to do any more with it, then just write down a function and weren't going to do any more with it. You don't necessarily need to do that. But I'm going to go ahead and distribute the X through. So I'll have 10x minus, and then here I've got 0.005x times another x. So that'll be x squared. So minus 0.005x squared. All right, and then one more equation that we're going to write for this one is a profit equation. And so profit, that's the money that you earn. And so if you just think about it, you can memorize this as an equation, but you can also just think about it. So you're going to have money coming in, and then you're going to have expenses going out. And so the profit is what's left over after you pay your bills. So money coming in minus the expenses going out. So in terms of the variables that we have here, or the language that we've used here, profit is revenue minus cost. All right, and so since we've already got a revenue and a cost equation, really all I have to do is subtract them. So I could write P equals, or again, our textbook likes to write P of X equals. All right, so revenue, and I could use the unsimplified version, or since I distributed through the X already, I'm going to go ahead and use this version, 10x minus 0.005x squared minus the cost. So I have to be a little bit careful here since I'm going to be subtracting the cost, and the cost is not just a single number, it's got more than one term here. I have to be careful that I distribute that minus sign through on that entire expression there. So 900 plus 0.37x. And again, I could leave my profit function written like this, but if I'm going to do some more things with it, it might be worth simplifying. So there's a couple things you can do to simplify. I'm going to combine them just to save a little space here. One thing that you could do to simplify is distributing this minus sign through to these two terms here. So we'll have a minus 900 and a minus 0.37x. And then the other thing that you can do is combine like terms. And so just kind of thinking about the terms that we will have, I've got a 10x term here, and then I will have a minus 0.37x term here. So those are like terms, and I can go ahead and combine them. You're just going to add the coefficients. And as I do this, it might be helpful too. Maybe you kind of recognize what kind of equation we have here when you're done. I'm going to have an x squared term. I'm going to have x terms that I'm going to combine, and I'm going to have a constant term. So that's a quadratic equation, just kind of refreshing that algebra memory about quadratic equations. And sometimes quadratic equations are easiest to work with if you have the squared term written first. So I'm going to go ahead and combine like terms, but as I do that, I'm going to put the terms in the order that maybe is most convenient to work with them. All right, so the squared term is going to come from right here, negative. Remember to keep the sign that's in front of that term with that term. So negative 0.005x squared. All right, and then here's where I'm going to go ahead and combine those like terms. So I have a positive 10x, so a plus 10, and a minus 0.37x. So I'm just going to add those coefficients. So you can do that on your calculator if needed, or you can do it in your head if you can do math like that in your head. So 10 minus 0.37. If you just think about that in terms of money, maybe it's easy for you to think about that. $10 minus 37 cents. right? So we'll have plus 9.63. That's from the positive 10 minus 0.37 x. Those were the coefficients of that x term. I'll go ahead and put a squiggly line on there just to remind you where those two came from. And then the constant term minus 900. Okay, so in this video, all I really did was just write down a cost, a revenue, and a profit function based on this word problem. But what we're going to be doing much of the rest of the semester is then analyzing those equations and think about what they tell us. So we'll look at a video where we do some fairly simple analysis now, and then as we go through the semester, we'll be able to do more complicated analysis of what these equations tell us.